Hello and welcome to Big Data Hadoop and Spark Developer Introduction to Hive and Impala lesson. In this lesson, we'll discuss the role that Hive and Impala play as components of Hadoop ecosystem and how they can be used to analyze the data. First, in the first topic of the session, we will look at the core features of Hive and Impala. After completing this session, you should be able to explain Hive and Impala along with the features available, compare Hive and Impala, differentiate between relational database and Hive and Impala frameworks, and execute queries using both Hive and Impala. The first lesson will look at the features that are available in Hive and Impala and how they can be used to analyze the data. Both Hive and Impala provide SQL-like interface that allow users to extract data from Hadoop. The SQL interface is same as most developers are familiar with. On this slide, you see a typical SQL statement. It's a typical SQL syntax that you all should be familiar with. And those queries can run either against raw files stored on HDFS, or they can execute against data in NoSQL databases like HBase. The one important difference between the two frameworks is that Hive is typically used for batch processing, like ETL jobs, while Impala is better suitable for interactive SQL. So first, let's look at the similarities between the two. Both Hive and Impala brings large-scale data analysis to a broader audience. And that means you don't have to be a Java programmer. You can use a familiar SQL interface to do your analytics. It's a lot more productive than writing MapReduce programs. In MapReduce, an equivalent of a few lines of SQL can involve 100 lines of Java code. So frameworks that use SQL on Hadoop are very handy in that respect. And finally, they offer interoperability with other systems. One example would be BI platforms that rely on SQL. So you can use Hive and Impala to connect BI platforms or other applications that rely on SQL to the Hadoop framework. Now, let's compare the two, Hive and Impala. Impala is relatively recent. It was developed by Cloudera in 2012, while Hive became available back in 2007, and it was developed by Facebook. Both are open source Apache projects. Now, Hive runs on top of MapReduce. It is an interface on top of MapReduce that enables a SQL-like interface instead of writing MapReduce Java programs. Impala, on the other hand, provides much higher performance because there is no intermediate step involved. When you issue a SQL statement in Impala, it goes directly to the data, whereas Hive when you execute a SQL command, it has to be translated to a MapReduce job, which then gets submitted. Now, Hive is more suitable for structured data, while Impala is designed for higher concurrency, and it is also suitable for ad hoc queries, while you typically use Hive for batch processes like ETL jobs. So which one to choose when you decide to run SQL against Hadoop? Well, one advantage of Hive is that it supports a lot more SQL features than Impala does. So it is a lot more extensible. The disadvantage is that it is much slower than Impala. But in Impala, on the other hand, you can use for interactive queries and interactive analytics. So it is more real-time, while Hive is more oriented towards batch processes. And finally, Impala allows you to support many users, while Hive is more geared towards a single user batch-like environment. So, is Hive really like a replica of RDBMS? And the answer is no, it is not. While Hive does support more SQL feature than Impala, it is still quite limited compared to RDBMS. A traditional database, at least most of them, you expect to provide full ANSI SQL support. So looking deeper into the differences and the similarities of Impala, Hive, and the traditional RDBMS. With traditional database platforms, you can access individual records. Not only access, you can update and delete individual records, while Impala and Hive are not appropriate for those purposes. The SQL that runs in traditional RDBMS supports transactions, while SQL that runs in Hadoop does not. That's not what the system is for. It is not a transactional platform. It is an analytical platform after all. Finally, support for indexes. In traditional database, that's fully expected, while on Hadoop, there is limited, if any at all, support for indexing. Another big difference is latency. Traditional databases are real-time, low latency, while in Hadoop, latency is much higher, especially with Hive, as it is more geared towards batch processing. And finally, the size of data that each platform can typically access. In the traditional database, it's quite limited, maybe terabytes of data, while in Hadoop, we're talking about petabytes, and both Hive and Impala are suitable for that purpose. Although Hive does allow better performance on very large data sets. So in the next section of this lesson, we'll learn about interacting with Hive and Impala. We will see how the queries are executed and what steps need to be taken to execute your SQL, and how you can use various interfaces. So when we compare the steps that the processing engine needs to take to execute SQL queries, the first three steps are very similar for both Hive and Impala, a SQL statement needs to be parsed, it has to be optimized, and execution plan needs to be generated. But that's where the similarities end. For all the subsequent steps, Impala goes directly to the data, while Hive needs to take several additional steps. The SQL commands need to be translated into a MapReduce code, and then MapReduce jobs need to be submitted to the engine and then executed, and the data finally returned and stored in the HDFS. So those are the main difference in how the query is being executed in both Hive and Impala. Let's consider a use case. An education company uses Hive and Impala to analyze social media coverage. And they look for neutral, positive, or negative reviews and rank them as such. So both Hive and Impala offer several interfaces for running shells. There is a command line shell, there is Hue web user interface, and the Metastore Manager is used to connect via ODBC or JDBC. So for command line shells, the Hive shell is used Beeline, while Impala's is called Impala-Shell. In Hue UI, you can access visual query editors. And later we'll see an example how you can access them from the menu. And Hue provides visual SQL editors for both Hive and Impala. Now, to execute a Hive query in Beeline, where, if you recall, Beeline is the name of the shell that we use to execute Hive queries. You use exclamation points to execute a command. Now, some of the popular commands are exit, help, and verbose. Verbose will show you additional details on the query, and help will list available commands and options. And this is what the Beeline shell looks like. Looks similar to most other SQL shells. In this demo, you will see how to connect with Beeline and how to execute a few basic queries. Now let's take a look at the demo. So we use the -u option to execute a query. The first example executes a query that is stored in a file. Our file is called Simplilearn HQL, where HQL, by the way, stands for Hive Query Language. The next example executes the SQL statement from a command line, and for that we use -e option. Note that the SQL statement that follows -e has to be enclosed in single quotes. And the last example shows how to continue execution even after an error is returned. And here we would type -force equals true. So here, these are a few basic examples. So, and this is what the interface command line shell interface looks like. very basic, very similar to any other one. Note that, like in many other shells, we use a semicolon to terminate the SQL query. So in the next slide, we'll see how to execute Impala commands from Impala-Shell. Again, if you look at the Impala-Shell, it looks fairly similar, very similar to Beeline. So next demo, we'll see how to connect with Hive and Impala-Shell. So again, with Impala, you have a help option, minus help. If you recall in Beeline, it was an exclamation point, help, to see the available commands and option. To execute a command directly from the shell, we use minus Q option. And again, our SQL command needs to be enclosed in single quotes. Now, minus D, we use this option to start a database. Now, in this example, we are connecting to the Simplilearn database, but if we do not specify a specific database, it will use the default database, whatever the default may be defined as. Here an example of query execution in the Impala-Shell. Again, simple SQL statement, and here is the output. Now next, we'll see how to connect using Hue interface. So under the Query Editor menu, you can select either Hive or Impala, and this will open the corresponding SQL editor. In the next demo, we'll see how to connect Hive and Impala-Shell using Hue. So in the prior demo, we saw how we find the Impala and Hive query editors in the Hue interface, and this is what those editors look like. The first diagram, in this example, we execute a command to create a table, and on the second diagram, we issue a describe command to describe the table. And as you can see, there's a very straightforward SQL editors, similar to pretty much any other. Our SQL command line is on the top, and on the bottom we have the results pane. And after we ask to describe the table we created, it returns the name of each column and the name of the table. So key takeaways, what you should be taking away from this lesson. Now first, Hive and Impala are tools to perform SQL queries on data residing on HDFS directly or in the H-based NoSQL database. Hive and Impala are easy to learn for experienced SQL developers. So as we've already seen, the SQL shell and the visual tools should be familiar to anyone who has done work with SQL on any other platform. Hive and Impala solve big data problem, but cannot replace a traditional RDBMS. So if you recall, when we examined the similarities and differences, some of the key differences with traditional RDBMS is the ability to execute transactions, ability to operate on single rows of data, inserting or deleting or updating single records. Hive runs MapReduce or Spark jobs on Hadoop based on HiveQL statements. So that's an important distinction here. So HiveQL, there is an additional step. It needs to be translated and then executed as a MapReduce or Spark job. Impala, on the other hand, uses a very fast specialized SQL engine that is faster than MapReduce. So Impala, on the other hand, does not involve any extra steps. It goes directly to the data, and that's why it is much faster. So that concludes the lesson.